Okay, welcome back everyone. In this video and this lesson we're doing equivalent expressions. Okay, so there'll be some algebraic expressions, and for you while you're still learning this that might look like a jumble of numbers and letters, and through this lesson I'm hoping that we can start to begin to see that some algebraic expressions are the same, and they're the same because they deliver, when we substitute in a value for x or n or whatever the letter may be, we keep generating the same values, the same numerical value on the other side of all the crunchy stuff that goes on, all the crunching the numbers. And I'm going to give you a couple of examples. And number one, I think it's good practice at substituting and evaluating, but hopefully somewhere you'll start to see something. You'll start to see, hang on, if I collect some like terms, which is the subject of the next lesson, if you start to collect the like terms and get a sense of what that is through today's lesson, you're set up for the next lesson, and you're starting to understand the algebra a lot better. So I'm going to get behind the light board and show you a few examples quite quickly, and then get you working as fast as I can to try and make this happen. Welcome back guys, we're doing some more work on algebra. We're looking at equivalent expressions in this lesson, and when I see this word equivalent, I see buried inside here, I see the word equals, being the same. So remember, if we just treat algebra as a box, we put something in, so we have an input, and we produce something, and we get the output. We put a number in and we get an answer out the other side. Now, expressions are equivalent when you can put the same number in and get the same number out. So the way I like to think about this is I often like drawing a set of scales. Okay, old style scales where we've got two little baskets on each end, and whatever we put in the basket, they balance. Okay, so the same is on each side. If the scales or the balance tips one way or the other, they're not the same. And that's how I like to think about equivalence. So we need to, there's a couple of ways to check this sort of style of work out, and one way is to do this. You compare two expressions, and really simple stuff. 5x plus 3, is that the same as 6x plus 3? So let's use some easy values, and I love using x equals 0 here. So that's our input, we put it in, and what do we get out? We get 3 on this one, and if we put x equals 0 in here, we get 3 out. So the first value we try, we get the same answer. So let's try another value. Okay, so 5 times 1 is 5, plus 3 is 8. I'll try x equals 1 here. Okay. What do we got? 6 times 1 plus 3 is 9. Whoops, they're not the same. So the balance tips over at this stage. We're putting the same number in, we're not getting the same answer out. And just to, was that a fluke, or is that going to happen all the time? Let's try one more. So 5 times 2 is 10 plus 3 is 13. And if we put 2 into this one, 6x plus 3, we've got 6 times 2 is 12 plus 3 is 15. So it's quite clear they're not producing the same answers. And in a previous video, I talked to you about trying to map out, get some sort of sense of what is happening in this situation here. And what I see is that both of them, 1, 2, maybe 3 here, these are our x values, our input, this is our output, and one of those, they both cross at x equals 0. One of them's doing this and the other one is doing something slightly different. Okay, it's just coincidence that they both, they didn't cross there. I made a mistake, so I will quickly rub that out and do that again, because where did they have the same value? It was at 3. So one of those graphs is doing this and the other one's doing something slightly different. So they're not the same. And that's the key thing. So what would we write in that situation? They're not equivalent, okay? There's another thing that leads us to our next example. I think this work out of this exercise is getting you to work in tables a lot of the time. But what it's leading to is collecting like terms. And you may be able to see this. And for example, if we've got 3x plus 4, and we're comparing 8 minus x, and we've got 2x plus 4 plus x, which ones are the same? Which ones are the same? I think this guy here, and see there's an extra x here. Collecting like terms, we've got 2 x's here plus another one here. I'm going to rewrite this as 3x plus 4. So I know looking at that, they produce the same values. And that is the next set of work that we're going into. If you didn't follow me there, think about this. Think about this. If we had 3 lots of 5 plus another 4, that's going to be 15 equals 19. I'll remove this and say we had 2 lots of 5 plus 4, which is 10 plus 4 is 14, plus another 5. Well, that's the same thing as saying, well, that's 3 times 5 plus 4. We're going to end up in the same spot. So collecting the like terms, if you can see it at this stage, will help you identify whether expressions are equivalent or not. If you can't see it or don't understand what I just said there, wait till the next lesson and we'll get you doing this step here, collecting like terms, and then you will you'll see what I'm saying. Until then, you can always map it out in a table. And if they're equivalent, they're always going to be producing the same values. Okay, thank you.